So as you can see, this is a side angle or ASS scenario. This is going to be a situation where it looks like the side opposite is smaller than the side adjacent, so we need to find the height. And we're going to find the height simply by using the trig functions. We know the side opposite 50 and the hypotenuse, so we're going to go sine 50 equals h over 20. We're going to plug that into a calculator. So we get a height of 15.3, and notice that the side opposite is less than the height, therefore no solution. So for this one, we've got, again, the angle side scenario where the side opposite is less than the side adjacent. So therefore, we need to find the height. Okay, so we're going to go ahead and draw in the height, right? And again, trig ratio says that the side opposite and hypotenuse is going to be sine of 35 equals h over 16. H therefore equals 16 sine 35, and we'll plug that into a calculator. And we've got h is equal to approximately 9.2. So in reality, we've got more of this. This probably comes down like so. It's going to come down more, a little bit closer here, and then we're going to have a another one coming in like this. So we'll have two different triangles. Got the blue one and the green one, where this is B prime. Okay, so 9.2, therefore two solutions. Okay, now on the side here, remember we're going to have to find B. That's measure of angle B, measure of angle C, and then side C. And then once we do that, we need to find B prime, measure of angle C prime, and side C prime, okay, of the green triangle. We will start with our proportion. The proportion that we're going to be working with says sine of 35 over 12 is equal to the sine of B over 16 sine of C over C, which doesn't do us any good because we don't have any information about that one. So we're going to be working with that ratio right there. And we're going to get 12 sine B is equal to 16 sine 35. And I'm going to go ahead and work this out. I'll pause it and work it out so we don't have to watch the whole thing. Okay, so as you can see, I rounded up to the nearest whole for the degrees, usually the nearest tenth for the sides, but this is turns out to be 50 degrees, and we'll be off by a few tenths here and there, depending on how we round. So we're going to put that in there. Now that I know two of the angles, we're going to go 180. This is 180 minus 50 minus 35. Turns out to be 95 degrees. So now we can plug that in here, and we can continue solving. So let's go ahead and work the next one. I'm going to use the first ratio and the last ratio. When we cross multiply, we're going to get C sine 35 is equal to 12 sine 95, and I will pause it and do the calculations for you. Okay, so C now is 20.8. We obviously rounded. Um, our biggest problems here, you guys, are just making sure you're closing parentheses and not creating more problems with calculator issues. Okay, so now we now know a couple of things. We know that angle B here is going to be supplementary to B prime. So if B is 50, then B prime is 180 minus 50, or 130 degrees. 130 degrees. We now have two of the three angles of the triangle, so we're going to go 180 minus 130 minus 35, which is going to be 15 degrees. So now I'm going to come back over here and we're going to go sine of 35 over 12, and we're looking for side C, so I really only need sine of 15 over C. Cross multiply. C sine 35 equals 12 sine 15. Okay, so we finished working that out. We get 5.4. So over here, 5.4. And again, those are rounded. And we have solved this problem. Notice that we had to find 6 different pieces when there are 2 solutions. One last look at the whole thing, and we're done for the day.